Okay, so let's go ahead and go over this assignment talking about the t-shirts. It's assignment 4.07. In the very first page of excuse me of the assignment, we're given a story problem. Dakota's dance troupe sold t-shirts as a fundraiser so that they could go to summer camp. When the girls began the fundraiser, 600 people wanted their t-shirts. They were actually short by 210 t-shirts, so the troupe ordered more, and then they raised the price in hopes of earning more profit. But when the price increased, the demand, or the amount of people who were buying the shirts, went down. Use the given information to analyze what happened with the fundraiser. So let's look at this graph. This graph is a very important thing to help us answer the rest of the question. In here, we see that we have two equations. We have one right there and one right there. Okay? And as we see, as the supply is the cost price right here, as the cost went up, the demand went down. Okay? And this is quantity and so on and so forth. Okay? So we need to remember that price is our Y and quantity is our X. Now let's go ahead and go through some of the questions here. When the fundraiser began, 600 people wanted to purchase the dance troupe's t-shirts at $12 per shirt. But as the group increased the price of their t-shirt, they noticed a fall in demand. For every $1 increase in price, that's important. For every $1 increase in price, the demand fell by 50 shirts. Okay, so right here we're talking about a slope. For every time Y went up, X went down by 50. So if we do our slope, we have change in Y. So let me just write that. Change in Y over change in X. And X is our demand. Okay? X is demand. Y was our price. We saw that on the graph. The dance troupe initial supply was short by 210 t-shirts, which corresponded to the initial price of $9.75. For every $1 increase in price, they ordered 40 more t-shirts. Write a system of linear equations to represent both demand and supply. So we've got two equations, one for demand, one for supply, for the t-shirts. Let Q represent the quantity of t-shirts and let P represent the price. And that matches the graph. P is the price, Q is the quantity. So if we look at our demand, we're going to start with demand. What do we see about our demand? Okay. First, where did we start with demand? Or the initial supply was this, but what was the initial demand? In other words, where does Y start? Okay, we're dealing with a linear equation, and we have Y equals mx plus b, and we want to know what the equation is for that one right there. Okay, that's our demand. Well, what does this part represent right here? This part represents the y-intercept. And this m right here represents the slope or rate of change. Okay, the slope or rate of change is how far it's going down for how far it's going over, or how far it's going up or over. You know, change in up and down over our change in right and left. Okay, so we're dealing with the demand right now. So that's this blue, or this first line here. we have y equals, what's our change? It goes down 1 for every what? Okay, and let's just see really quick. For every 50. Okay, so it goes down 1 right here for every 1, 2, 3, 4, 5. And each one of those lines is 10. So negative 1 over 50 x, or q, excuse me. I mean, they wanted this with a p right there and a q right there. So we have our p and our q. Now where do we start? Our y-intercept is what? 12. So plus 12. So there's the equation for the demand. We do the same thing for supply. Now we're dealing with supply. We do the same thing. Only here, we don't know exactly what that y-intercept is. Well, that's where the story problem comes in to help us. So if we go down to the story problem, we see what that is. We see the first one was $12 per t-shirt, and now we're at $9.75 per t-shirt. So we have our supply is y equals, and how much does it change? For every $1 it goes up. That's what increase means. So 1 over 40. Q. Sorry, this is supposed to be P. Okay, so 1 over 40 Q, and what's our y-intercept? Right there. That's our price. 9.75. And that would be the two equations. And the reason why those are coming up is because we're starting with the price. Remember, the y is our price. So y equals our price. We'll do plus price. Okay. And how much it's changing. So the change in price over change in quantity, or number of shirts. And there's always an X, or in this case, a Q. So that's how you do number one. Number two, use the system of linear equations you wrote to solve for the variables P and Q. Show all your work. Okay? So what we want to do here is find out this. So that's number two. We want to know what that point is. But you got to show your work. It's not just as easy as looking in the graph. Well, what do we notice about this point right here? We see that both supply and demand are the same. At that one point, those two equations come together. To figure out where they're the same, you've got two equations. Y equals mx plus b for the supply, and y equals mx plus b for demand. Now we want to know when this part is equal to this part. We don't care about the y equals. That's just telling us, hey, here's the equation. So we want to take the supply, mx plus b, And we want to set that equal to demand. Okay, in other words, let's just say that this one is, and I'm going to change this. Well, let's say it's blue. Okay, this one's the blue one, and this one's the red one. Okay, I'm going to take the blue, mx plus b equals the red, mx plus b. And those are the equations that you came up with in number 1. Okay, so you'll set those equal to each other, and then you'll solve. Now, the way to solve this, you're going to have some denominators, okay, because the change or the slope is a fraction. So multiply by both denominators, both sides by both denominators, okay, and that will get rid of the fractions. So I'll give you, we already went through it. Your denominators are going to be 50 and 40. So multiply both sides by 50 and then both sides by 40, and that will get rid of the fractions. So 50 and 40. And so let me show you how that's done really quick here. It sounds harder than it is. Okay, so if we have an equation, let's say we have 1 over 50x plus 10 equals 1 over 40x plus 5. These are not the correct equations. I'm just showing you how to get rid of the fractions, okay? So this would be our supply. This would be our demand. How do we get rid of this? Well, we take this whole thing and this whole thing times 50 and 40. How did I get those? Well, those are the denominators. It's called clearing out the fractions. Once we have the denominators, we can cross off the denominator. So now we have 40 times 1 is 40. So we cross off the 50, 40 times 1, so we have 40x, and then 40 times 10 is 400 equals, and here we have a 40 and a 40 that crosses off, giving us 50 times 1 is 50x, and a 50 times 5 is plus 250. So you can see, as long as you multiply by both numbers, all you do is multiply by both denominators, cross off the one that matches, multiply everything times the other one, and now you have an equation with no fractions whatsoever, and you just solve for x. So, minus 10x, minus 10x, minus 250, and then you'll eventually get x, or in their case, they want q equals, q and x in this case are the same thing. They want that to be a number. That's what it wants in number 2. Okay? Once you have the q, then you take that number and plug it back into one of them. Okay? So then you would have 1 over 40 times whatever number you got plus 5, and then multiply that out, and then you're going to get the p equals something. So you can look at the graph and double check your work. You'll be able to see right where they cross. But that is how you do number 2. Number 3, what do those values represent? What does that equilibrium mean? Okay, so in your own words, tell me what that means. What does that point represent? What happens when the quantity is above that, and what happens when the quantity is below that? That's 4 and 5. So 3, 4, and 5, you just use your own words to explain it to me. 1 and 2, we went through it. Hopefully this helps. Let me know if you have any questions.